have not landed on the site, but also this is not the final design. I mean, this is our four-man solution for the wheels, using bicycle rims and putting some pedals on them. But of course, did the calculation on the loss of power through a 1 kilometer tether, and that's not a problem. We can actually achieve that. I think the difficulty will be if we put batteries on board, then how long can we make the batteries last and how fast can you go down? There are some still things need to be looked at. The other thing is I would envision, depending on what you have up there, is how well can you see in 500 meters. We're going to go over these different rocks. And while there's a number of rocks here, none of these rocks are actual. And there's also another grab of myself. Now we're approaching here this rock, and you will get an idea of the capability of this thing to go over this type of rock. So this is not the largest rock it can go over. And it's the rock and it's the rock. Now one of the things to point out about this Axel Rover, it is symmetric, so there is no right side up or upside down. So if you flip it in reverse or you flip it over, it's always left side. There's no such thing as flipping over. Now I did mention that there's only 3 motors. One of the big savings we get is we don't have steering mechanism. Eventually, that's one of the main things that is really easy. The other thing we do have a full steering system. And I would like to point people to the monitor next to me, and you will see that it actually acquires color images that are being sent, back to the rover. Because we can control the link independent of the rover, we can adjust the pitch of the camera and we're not doing it 180%. It is also possible to add additional motors and get a little bit more degrees of reading and underreading. Now, if this thing drops off a small ledge, it doesn't. So we are able, and remember, the reason why we have so much room inside is because we're really using a very small number of actuators. And this is rated at 500 pounds.
Is the power coming from up there or inside
the
rover?
No, the power is show you this idea of a minimalist type of rover that actually could be used to go into craters to explore deep and steep craters. Now you see the rover is descending from what we simulated as a crater promontory. It was sitting on a lander. If you look at the side here, this is the polar lander mock-up that we put up there. Of course, it should have been a little bit propped higher, but that's the best we could have done and keep it stable. Now this rover actually went down over this promontory, and you can see it's going down a vertical this is about 85 or 80 degree slope over this rock. And it actually, if you really look at this carefully, this operates like a yo-yo, so it really doesn't need to have any surface. So right now here it loses contact with the surface, and it just free hangs and lowers itself. And once it hits the terrain, it will gain traction again, and it will drive forward, and it can also do turns in place. Now you see the blue body is actually rotating full circle. What it's doing actually, it's unreeling that tether. And we have, in this rover, we have only 3 motors controlling it. There's one controlling the left wheel, one controlling the right wheel, and one controlling that lever arm that rotates the lever arm relative to the body. So if you look very carefully, the position of that arm relative to the position of the camera changes continuously. So now it's going down the slope, and it's using, it's pushing that lever into the ground to gain forward traction, but it also keeps the balance with that tether. Now we stopped here to actually show you how we're going to collect a sample. So what we do is we bring that lever arm and dig it into the ground, and then turn in place. And that turn in place digs that lever arm, we dig the lever arm into the ground, and then the turn in place fills 2 sampling tubes that are on this protrusion that's sticking out of the lever arm. And these will collect our samples. We repeat that a few times. That digs us deeper into the ground, and we can collect that sample. So now it's pushing and it's filling one of the tubes, and then we're doing and then filling the second tube. And that's how we can collect that sample. And we can do that. Now we've explored different sampling devices, and actually we had students at Caltech also look at rasping into rocks. So we both looked at and tried to sense the tether tension and look at that. Then another thing is, how do you actually automate these trajectory generations? How do we plan our paths? We need to put obstacle avoidance for sure on this thing. We need to see how well it performs with infrequent communication to it. So there's a lot of steps that still. So the best way to think about this rover is think of a yo-yo. This rover operates like a yo-yo. It has one of the actuators, the motors that controls the lever arm. It has also another function, which is reel and unreel the tether. And by reeling and unreeling its own tether that it carries with it, it's able to lower itself over any type of terrain. Actually, in fact, it doesn't need any terrain. This can be lowered from a balloon. The same way you drop a yo-yo and as it goes back up, this rover operates in the same way. This is a rover that's fully symmetric, so there is no way to flip this over. It operates upside down, right side up. It's also what we call a minimalist rover, meaning that it uses a very small number of actuators. In fact, this rover has 3 actuators in it, 3 motors. One that controls the left wheel, one controls the right wheel, and then one controls that lever arm that you see that rotates relative to the body.
Right now, it's really risky for astronauts or lander or robots, for example, like the Spirit and Opportunity, to go into craters. The ground is too loose and the slopes are too steep. So it's too risky for those robots to get into those craters and perform any interesting science. So this robot would be very useful for those types of scenarios where it can really dive into those craters, pick up some samples and really analyze them and tell us something really new and interesting about the Mars or the Moon, for example. This robot has met and exceeded all of my expectations, basically, just in terms of the way that it's performed. Going down 0-degree slopes, or 90-degree slopes, I should say, to traversing to flat ground and getting over rocks and all that kind of stuff. It's been great, and I'm really happy with it.